Our topic for today will be looking at chemistry 1502. The topic is isomers, lesson 101. Let us start. With the knowledge that we have of the first three homologous series, which are alkanes, alkenes, and alkynes, with this existing information or knowledge, it is good enough for us to introduce isomers, or some say it's isomerism. So you should know that isomerism is the phenomenon of existence of two or more compounds with the same molecular formula but different properties. Those properties can be physical or chemical properties. And it is also known as isomerism, and the compound exhibiting this phenomenon are called isomers. You should know that we have two main types of isomers. The first one is structural. Some say it's constitutional isomer. That is the first type. The second type is stereoisomerism. Let me actually correct the spelling. It's iso. Then we still have subtypes under these two types. Under structural isomer, we have three main isomers, but all in all, we have more than three. There are actually six. Well, the first main subtypes is chain isomer. We have functional isomer. Then we have positional isomer. And then when we add the three remaining ones, we have metamerism, tautomerism, and ring chain. We are also going to have a look at those as time goes on. But the most important ones, or the basics ones, is the first three that you should master. And then under stereoisomerism, we have configurational, and conformational. And then under configurational, we have geometrical. If you can look in your textbook, you will see this. And then we have optical. So these are the types of isomers that we have. But in this lesson video, we are going to start with the structural, and then specifically this lesson video is for the chain isomer. That is the lesson 101. The introduction of this isomerism will consist of one type of an isomer, which is the structural. Then under structural, we'll be looking at chain. Then it means that lesson 102 will be looking at functional. Lesson 103 will be looking at positional. Then as you continue, we are going to move to stereoisomerism. Then we'll be looking at configuration and conformation. Then looking at these two, which is geometrical and optical. There are things that you should know about the structural isomerism or structural isomers. You should know that structural isomerism, it is due to the difference in arrangement of atoms or groups within the molecule without any reference to space. You should also know that the structural isomers are compound having the same molecular formula but different structural formula. In the lesson videos of alkanes, alkenes, and alkynes, we've looked at different types of molecular formulas, also looked at condensed formulas, we looked at structural formula. So this is the main definition of structural formula. They have the same molecular formula but different structure. As you can hear, the word structural isomer. So let us start by looking at our first type of structural isomer, which is chain isomer or chain isomerism. What is chain isomerism? Chain isomerism is when the isomers have the similar molecular formula but differ in nature of carbon chain, which we call them chain isomers, or the phenomenon is known as chain isomerism. Now, without wasting time, let us explain this using an example. As we all know that mastering a certain concept, it goes with looking at examples. Suppose we have C4H10. C4H10, we know very well it belongs to which homologous series, and we also know what is this. This is the molecular formula. And we know how to write down the condensed formula. We can even draw Lewis diagram for this. Now, the name of this, we know that if we have 4 carbons, it will be but, but since this is under alkanes, it's butane. So with the information of isomers, we can actually write or draw Lewis diagram for butane in different ways. Or let me say for this molecular formula. Let me not say butane specifically. For this molecular formula. So looking at butane, we know that we are going to have 4 carbons having single bonds with each. Then you can just hydrogens. So this is butane, and we know that if we were to draw a skeletal structure for this, we're going to have, it's 1, 2, 3, 4. But do we have another way to have 4 carbons and 10 hydrogens? Yes. And then it is only possible if we look at isomers. So suppose we have the structure. Instead of having carbon here, let us actually take it and put it here. It will yield a structure like this. We no longer have 4, but we have 3 because we've shifted this one here. By the way, we do have a structure like this. Then you should understand that introducing isomers, we are actually forced to also look at nomenclature, the way we name these compounds. Looking at the structure, you can see that it still has 4 carbons. And then looking at hydrogens, we still have 10 hydrogens. Then the molecular formula is C4H10. And then we say the 2 structures are isomers, specifically chain isomers. Looking at the chain, when you refer to the chain, you look at this, the longest path, we call it a chain. In this case, you have 4 carbons in this chain, but looking at this one, you can see we only have 3 carbons in the chain. I meant to say longest chain. So what is the name of this? It cannot be butane. Remember, butane, we look at the longest chain, and then we look at how many carbons we have. We have 4 carbons, and then there is a single bond between carbon and carbon. That is why we say it is butane. But in this one, it's a bit different. Looking at the longest chain, you can see we have only 3 carbons. And then we say this is a branch. A branch is an attachment to the longest chain. So what is important is to identify the longest chain and also identify the attachment. And we have different types of attachment, by the way. We can have an attachment like this, which is the one that you see here. Or we can have an attachment like this, whereby we have carbon and carbon again. Two carbons. So we can have a longest chain and have this type of an attachment on the longest chain. Now these attachments, they also have names. This attachment, we call it a methyl. Yes, as you can see, the prefix is meth. Remember that if we have one carbon, we call it meth. Then when we're dealing with attachment, we put YL. That is why it is methyl. And then for the attachment where we have two carbons, you can clearly see that this will be ethyl. Just because it's an attachment, that is why the ending name, it ends with Y and L. Suppose we have an attachment whereby we have three carbons, then you can see the trend. This will be propyl. Please write these notes down. They will actually assist us. Now let us go back to our structure. Let's start by identifying. By the way, you are looking for the name for this. What you're going to do, you're going to identify parts by parts. Now let us look at the longest chain. You can see that the longest chain consists of three carbons. And by the way, we can also identify the longest chain like this. And then this will be our branch. We can also identify it like this. It is also possible. This would be our branch. So either way, it doesn't matter, but we can identify it like this. Then we can see the branch. Then we have to start naming. You can say this 1, 2, 3. Before we get to that, let us start by identifying the longest chain. The longest chain here is 3 carbons. It consists of 3 carbons. So we know that our name will have, then we have single bonds, it's propane. Should know that our name will consist of this parent chain. And then we have to label our carbons now. We can have 1, 2, 3. We can still have 1, 2, 3, or we can have 1, 2, 3. You can see it doesn't matter. We can still have 1, 2, 3. The reason for this, we are trying to identify where is the branch, the methyl group. So you can see that even if you take it this way, this way, this way, or this way, our methyl group or our branch is on the second carbon. Then how do we name this? This will be methyl. Like we said, the branch consists of only 1 carbon. And then where is the location of this methyl or this branch? You can see that it's on carbon number 2. Now you should know that between numbers and weights, there must be a dash. So this part, it's 2-methyl. Our methyl branch is on the second carbon. And then the longest chain is propane. So we have to join the 2. So our name will be 2-methyl propane. There's no space between the weights. There's only a dash between numbers. So this is the name of this particular compound, 2-methyl propane. Let us look at another example. But before we get there, you might hear words like N-butane, which is also referred to butane. And then this one, instead of saying 2-methyl propane, we can say it is isobutane. It is an isomer of butane, so that is why we say isobutane. Okay, the next example, let us look at pentane. You can go ahead and pause the video, try to work out the examples, try to work out the isomers of pentane and play the video to see if you got it correct. So you have C5H12. Before we continue with this example, I would like us to go back here. Since we have a skeletal structure for butane, then the skeletal structure for 2-methyl propane will be like this. Remember that we have carbons here, and then this will be our branch. So let us go back here. So this is pentane. Now we can decide to take this and put it anywhere from here to the last carbon. But remember that we cannot put it here. If we put it here, we are going back to the parent chain or the longest chain. Then we still have pentane. And we cannot put it here because we are still going to have something like this. So we can either put it here or here. So let's say we put it here. Then we are going to have something like this. Now you can see the parent chain has changed. Instead of 5 carbons, we have 4 carbons. So identifying the parent chain without even looking at the position of the methyl group, we can just say this will be butane. Then let us start to identify the position of the methyl group. So let's say we take this chain starting from left to right, 1, 2, 3, 4, or we take it from left to right, 1, 2, 3, 4, or we can take it this direction, 1, 2, 3, 4, or we can take it 1, 2, 3. You can see clearly this is not our longest chain, so we cannot go that route. Or we can take it this direction, 1, 2, 3, 4. Now there are guidelines in which we should follow in order to answer this question, or in order to identify the position of the methyl group. We always go with the lowest numbers. Starting from here, we are going to have 1, 2, 3, 4. You can see that it's on carbon number 2. If you take it from left, you are going to have 1, 1, 2, 3. So comparing 2 and 3, we can see that this is the lowest number. So even if we take it this direction, it will not work because we're going to have the methyl group on carbon number 3. But if we take it this direction, you can see this will be 1, this will be 2, and then this will be our group. So whenever we write the names, we should be very careful and be very open-minded to check the longest chain, because sometimes the longest chain might move like this instead of specifically being like this. So you don't have to identify the longest chain being a straight chain. You should know that you can have different direction. So you can see that this will be 1, 2, 3, 4. So the methyl group is on carbon number 2. Even if from here we take this, we put it on this carbon, you can see that we are going to start from here, because we are trying to go for the lowest value. So we have 2 methyl, then joining this we are going to have butane. But is this the only chain isomer of pentane? How about we take this carbon, we put it here, or let us put it where we can put it here, and then we take this one also, we put it on the very same carbon here, meaning that you're going to have something like this. Let us see if it will work. We have to count the number of hydrogens, count the number of carbons. You can clearly see that carbons, we still have 5 of them. Then also looking at hydrogens, we can see that we have 12 of them. So we still have C5H12. Go ahead, pause the video, try to work out the name for this and play the video. So looking at the chain, you can see this is the chain. Even if we take it this way, we can still see that we have 2 branches. We take it this way, we have 2 branches. We take it this way, we have 2 branches. You can see either way it will actually work. So our parent chain here is propane. And then let us try to locate the branch. So we have 1, 2, 3. Looking at the branch, we have 2 methyl branches, or 2 methyl groups. Even if you take it from the left, we have 1, 2, 3. So we have 2 methyl groups on the second carbon. So with this information, it is very simple. Now what happens if we have 2 methyl branches on 1 carbon? So this will be 2.2. Before we continue, let us go back to the basics of chemistry. We know that 1 in chemistry, mono means 1, 2 means a di means 2, tri means 3, 4 means, tetra means 4, penta, hexa, pepta, and so forth. So in this case, we have how many methyl groups? We have 2 of them. So this will be 2.2 dimethyl. So the first methyl group, we find it on the second carbon, and also the second methyl group, we find it on the second carbon. and then we have two of them. That is why we say dimethyl. Then we simply join this here. It will be 2.2 dimethyl propane. Well, this is the end of this lesson video, whereby we look at the structural isomer, specifically the chain isomer. The next lesson video will be looking at the next type of isomer, but I will have to make another lesson video whereby we look at more examples of this chain isomer, so that we can practice how to name these isomers. And by the way, we are already covering also the IUPAC name of these compounds. Well, that's it for this lesson video. This is Paula SJ. Thank you very much.